Now students, as we have seen refractive index, so let us talk about absolute refractive index now. You know that refractive index was the comparison between two mediums. Yes? So according to mediums, we are having two different speeds, and accordingly we can judge what would be the bending of the light in that medium compared to the other one. Okay, so why not we can take it the like one strong thing that is certainly be equal for every other mediums, and according to that we can just make one single index. Let's suppose if I want to take the comparison between the mediums, and accordingly I want to take the speed of the light in water medium in comparison to the honey. But in other case, like if there is other student and if it wants to take the speed of light in the medium kerosene, and it is again with respect to honey. So now this is going to be changed again and again, and there are lots of other mediums, and accordingly we are going to take the mediums like this. So how many times we can just change the medium and we are not getting a certain value for a particular thing. Like if I only want to take the refractive index of kerosene. Okay, so for just a particular medium, I want to see that the light bending would be this much or that much, whatever the value is. Okay, so for that, why not we keep a single comparison thing? So here we keep a single comparison, and that is vacuum. So refractive index of any out of medium with respect to vacuum, because you know that vacuum is nothing but here in this case the light is at the highest speed, because there is nothing medium, no air or no molecule. Vacuum is nothing actually. So the speed of the light here in this case would be the highest. That is why we keep the one medium and compare the other mediums according to the vacuum only. This is known as absolute refractive index, and this is actually the basic index values, and these index values are not going to be changed. Like in earlier cases in refractive indexes, when we were comparing one to another, so every time we are getting different values of the light ray to get bent. But when we are comparing these all with single medium, that is vacuum, so every time we are going to get a single sort of value, that is the giving absolute refractive index. Absolute मतलब जो कि fix हो चुका है, बिल्कुल change नहीं हो सकता है. Okay, so here for this thing we have to compare it with vacuum, so we will keep the vacuum on the numerator part, and the other medium, any kind of medium like water, kerosene, glass, whatever you want to take, and need to find how much the light is going to be bent in that medium, so we have to keep it in denominator. The formula is same that we have seen in the refractive index. The thing that is going to be changed is the only thing that numerator part is going to be vacuum now. Okay, so here according to that I have a list of these material mediums, and according to that, when we compared it with the vacuum, so what refractive indexes we are getting. Here you know that vacuum is nothing, it is 0. So if I want to compare vacuum and I just put it at the below side, that is air, speed of the air with respect to vacuum. Okay, so here I am getting the value of 1.0003. Okay, so that is nearby to 1, because 3 decimal, after decimal place there are 3 zeros. So this is almost equals to the vacuum. That is why it is 1. 1 means that the refractive index for both the mediums are same. That is why these are cancelling out each other and we are getting one value. But yeah, here we are having not 1 but 1.0003. That shows us that it is almost going to be 1 but not exactly same. And you know that air is almost equals to vacuum, but not exactly that. Okay, so comparison now ice is 1.31. it is a lot more than the vacuum. That means that gives us an idea that light is going to be bent very much here. Water 1.33, alcohol 1.36, kerosene 1.44. See at the random pace that how I am going to be extend here. So the refractive index is going to be increased. Absolute refractive index is going to be increased. This shows that the light is going to be bent more and more. Okay, and now the ground glass. You can see in ground glass you are having 1.52. Okay, this is too much. And in diamond, this is the highest refractive index. That is why once the light that is entering inside the diamond, so it is going to be refract again and again inside, reflect again and again inside only. Okay, so in diamond, that is why it is very expensive. You know that once the light is entering, so in different direction the light is not even getting, a little chances are there that it is getting outside of it, because its shape is such a like that light is again and again reflect at an angle according to the incident angle, and it is going to be reflect again and again inside it. That is why it is so shiny. Okay, and ruby, sapphire, dense fine glass, all these are having a very high absolute refractive index. That is why light is going to be bent in that medium very well. Okay, rarer means that is it is not going to be bent at all, and it is almost equals to the vacuum, that is air. That is why it is 1.003. Okay, so here some of these are the list, and these are very important material mediums, and this could be asked in your exams also, not directly but in form of questions, like what would be the absolute refractive index of kerosene or honey with respect to water. So what you are going to do in that case, if you get to know the material medium like refractive indexes of these two things. So what I have told, honey with respect to water. So water's refractive index like this is 1.33. and honey's refractive index you can put it here. Okay, so directly you can just put the refractive indexes of the particular values that is asked. So here no need to ask the refractive indexes of the particular one with respect to vacuum. You just keep this learn, and then you are directly be able to give the idea. Like आपसे अगर अब directly कोई पूछ लेता है कि honey और kerosene का comparison बताइए, तो आप directly उनके जो vacuum से refractive absolute refractive indexes values हैं, you can just put that and you can find the value. The answer you are going to get is the same thing that you will get by keeping the value like we have done in the case of refractive indexes. Okay, so even you don't have to learn all these values, just the glass, that is the flint glass value, and the air and ice and water. These are very much important, and rest of the things would be getting like you are going to be get hint as a hint the refractive index of these material mediums.